So today we're going to talk about another power index. Last time it was the Shapley-Shubik, and unfortunately you just have to remember the names for these things. They both are just named after some people, and you have to keep straight somehow which is which. But today I want to talk about another power index, and it's named after somebody else. This is called the Banzhaf. That's the name of this guy. The Banzhaf Power Index. This is yet another way to measure the power of different individuals in a weighted voting system. And this is actually the last thing that we're going to do in terms of weighted voting, and then we're going to move on to something that's really completely different, which is gerrymandering. But anyway, let's talk about the Banzhaf for today. This is another power index. And it's different from the Shapley-Shubik, which is what we did last time. But it has the same goal, and that is if we start with, just like the Shapley-Shubik, the goal is to start with a weighted system, something like, about something like that, right? And you did some of these on the homework with the Shapley-Shubik. The goal is to start with a weighted system, and then from that, you make percentages of who has what amount of power. And this is the purpose of the Shapley-Shubik, which is what we did last time. And this is also the purpose of the Banzhaf. Why are there two different ways to do it? It's really because power is a complicated thing, and there are many ways that you could try to measure the power. And so the Banzhaf and the Shapley-Shubik are two different ways to measure power. They actually will give you different answers, and it's not like one is correct and the other is incorrect. It's just because there are different ways to measure power. So I will just say the Banzhaf and the Shapley-Shubik are two different measures of power. And they give you different answers. The ones that you did on the homework of the Shapley-Shubik, if you do the same ones with the Banzhaf, you'll get slightly different answers. They're not like wildly different. They are two different measures of power. I'll just say they're giving slightly different answers. Slightly different answers. All right. Anyway, let's talk about the Banzhaf. So it's kind of like the Shapley-Shubik, but the details of how you do it are different. And I think actually it's kind of an interesting story about the Banzhaf. So Banzhaf is the name of a guy who is still living. I just looked him up this morning on Wikipedia. He has his own Wikipedia page. Currently 84 years old, but still very much with us. And Banzhaf is not a mathematician. He is a lawyer who was really interested in social causes as a lawyer. He was one of the first people to try to convince kids not to smoke. In the early 80s, he was one of the big sort of people campaigning for anti-smoking laws and things like that. Also went to MIT, so I guess is interested in kind of mathematical type things. And actually this whole Banzhaf power index arose from his own personal grievances in local politics in Long Island. Maybe some of you are from here. He lived in Nassau County. Nassau County. Anybody from there? Yeah, all right. Represent. I'm about to rattle off some names of places in Nassau County, which I have never been there. But anyway, the way that this is back in the 80s. The way that their like local county elections worked was that they used a weighted voting system, which is kind of like the electoral college where each individual town would vote on issues and then the towns would add together points based on their populations, which seems like a, I don't know, more or less reasonable system to do. But anyway, this had weighted towns. Each town would vote separately, and then those votes would be kind of counted according to weights by the towns. And I'm going to tell you how they went. The biggest town was Hempstead. Anyone from Hempstead? No, that was the biggest one. Hempstead was so big actually that they divided it into two halves. So there was, these are like districts. Hempstead number 1, which had 31 points in the weighted system. There was also Hempstead number 2, which had also 31 points. Hempstead was just cut down the middle so that the weights could be more evenly distributed. They divided Hempstead into 2 regions. Okay, then they had North Hempstead, which I guess is a different place. Anyway, North Hempstead had 28 points. And then they had, the next biggest one was Oyster Bay, which has 21 points. The next one was, and then there's 2 little ones, Glen Cove with 2, and Long Beach also with 2. Are you from any of these places? No? Yeah. No? All right. I don't know anything about these places, but these are the weights. And in this system, in order to, these are like the towns are voting on laws and such, county level stuff. And to pass a law, you need a majority of the points, which in this case was 58. If you count up all those points, add them together, half of that, plus 1 is 58. All right, so to pass a law, you need 58 votes to win. All right? And Banzhaf looked at these numbers and said, this ain't fair. Anybody notice anything that's kind of unfair about these numbers? Yeah?
Well, obviously there's a big difference between Glen Cove and Long Beach than everybody else.
Yeah. These two twos are much smaller than all of the other ones. And you should be wondering when you look at these numbers, is it even possible for this 2 to influence anything? And if you look carefully, you will realize if these numbers need to add up to 58, actually these ones are so big and these ones are so small that the 2 really can't influence the outcome at all. All right? And so everybody who lives in, what that means, everyone who lives in Glen Cove and Long Beach, they go to vote on voting day, but their vote actually doesn't count for anything. It can't possibly influence the results of the larger decision that's being made. And it's less obvious, but actually if you look very carefully at these numbers, you will see even this 21 is too small to influence the outcome because these numbers are so big. So Banzhaf, my boy Banzhaf, looked at these numbers. Apparently nobody else had really realized this. Banzhaf looked and realized that actually the 2, and the 21 in this system are all dummies. That means everybody who lives in Oyster Bay, Glen Cove, and Long Beach, technically they are allowed to vote, but their votes don't ever matter for anything. And this is not the way it's supposed to work in a legitimate democratic system. You shouldn't have just like a bunch of people whose votes don't count. Everybody's vote should have an opportunity to mathematically influence the elections. All right, these are all dummies, and if you do the numbers here, I added these numbers up. This is actually around 22% of the total population. Right? Most of the people live in like Hempstead and variations of Hempstead, but everybody else, their votes count for nothing. 22% of the total population, their votes count for nothing at all. And so Banzhaf got upset about this, and he sued the state of New York because he said, my rights as a voter are being taken away from me because, like, even though technically I'm allowed to vote, my vote doesn't actually count for anything because I happen to live in one of these smaller towns. And so anyway, Banzhaf sued New York for, really, this is an issue of disenfranchisement. This is a big word that I've used at least once before. Disenfranchisement. That is the, disenfranchisement means when somebody is prevented or prohibited from voting unjustly, or if maybe you allow them to vote, but by some technicality their vote ends up not counting. All right, and in my opinion, this is a pretty clear case of unjust disenfranchisement, just because of the way the system works. And Banzhaf won his legal case eventually, and as a result of this, in 1993, New York State officially banned weighted voting. So these towns don't do it this way, and actually it is now illegal for towns to vote in this way because it can lead to this kind of situation where you're depriving people of their rights to vote. All right? Interesting little story, in my opinion. But anyway, Banzhaf, in order to do this lawsuit, he had to explain to a bunch of lawyers and judges why this system was unfair. And the details of that are a little complicated. You have to sort of look at these numbers and realize that in order to get to 58, there's no way the twos can add up to 58, that kind of thing. And Banzhaf, in preparing this lawsuit, he created what we now call the Banzhaf Power Index. So the reason that he created this little bit of mathematics in order to convince everybody else that the system was being unfair to him. So in the lawsuit, he created this, his power index. I think it's a cute little story of a lawyer with a slight mathematical interest, sort of taking the math into his own hands in order to win his legal case, which, I think it was a good change in New York state law, in my opinion. Probably doesn't matter all that much, but makes sense to me. All right, so let's talk about the system that Banzhaf came up with is similar to the Shapley-Shubik, but it's not the same. And Banzhaf, to my knowledge, was not aware of the Shapley-Shubik. He didn't take this class. Most people have never heard of the Shapley-Shubik thing. So Banzhaf just made up his own thing, which turns out to be pretty similar, but not quite. Anyway, the Banzhaf, let's just try and do an example here. So I'm going to do an example of 16, 12, 10, and 5. All right. The Banzhaf, in my opinion, I kind of like the Banzhaf a little bit better than the Shapley-Shubik. The Banzhaf considers all possible, what they call voter combinations. Now, the Shapley-Shubik, if you recall, is all about you write down a big chart of all the voter permutations. That is, how many different ways can I write the voters in different orders. Combinations are not like that. So these are not orderings. These are different groupings. And I will just emphasize unordered. The Shapley-Shubik is about listing out all the different orderings and then saying something about pivotal voters or whatever. The Banzhaf is about just combinations of voters. What are the different ways that you could group the voters together? And I'm going to make a list of those. So I'm going to call them the combos. These are all the different ways I could just make a group out of these voters. And as always, I'm going to call them ABC because that's how I do it. And I'm going to write down all the different ways you could group them together. So the first way that you could group them together is just by grouping everybody together. I'm thinking of all various ways you could just grab some of them, all right? And one way that you can do that is just combination consisting of everybody. All right. Then there are combinations which consist of only two of them. So I could do A and B, or I could do A and C, or I could do B and C. I'm going to try and sort of line them up like this. Remember, these combinations, we don't care about the orderings, so I'm always just going to write them like A first and then B and then C. Here we have one combination where you take everybody. There are three different ways you could take only two of them. There are also three different ways you could take only one of them. These are kind of less interesting combinations, but I could just take A by itself. That still counts as a combination. I could take just B by itself. I could take just C by itself. All right. And then one last sort of technicality. It does technically count as the combination of nobody. So I'm just looking at how many different ways I could just choose some of them. And you could choose nobodies, which I'm going to write like that. So this is the combo of nobody. Nobody, I wrote. Nobody. All right. These are the various voter combinations. This is different from voter permutations, which are all scrambled up in various orders. This is just voter combinations. And then I'm going to, just to help us out, I'm going to, in each case, write down the total weight of each of these combinations. So I got to unscroll a little. The total weight of each combination. So in ABC, the total weight of that, you just add up the weights of A, B, and C. That's 12 and 10 and 5. That's 22 and 5, which is 27. All right? Each row here, I'm just going to add up the total weight of those. What do you get for A and B? Somebody want to shout it out?
22.
22 for A and B. Yeah. Somebody else tell me A and C?
17.
17. Thank you. B and C would be 10 plus 5, which is 15. A just by itself is 12. B by itself is 10. C by itself is 5. And nobody is 0. All right, so those are the total weights in each row. And then the real deal for the Banzhaf is deciding who is, this is slightly different language from the Shapley-Shubik. It is critical voters. In the Shapley-Shubik, we call them the pivotal voter, but Banzhaf called them the critical voter in each of these combinations. And I want to say, can we just sort of leave this for now? I want to talk a little bit down here about how you figure out the critical voters, and then we'll come back and fill them in. So, to determine the critical voter, you have to go down the chart there, and in each row, you figure out who are the critical voters. So to determine the critical voters, these are voters, well, I'll write a little definition here. A voter is critical when the combination meets the quota and that voter was required to meet the quota. All right. So a voter is critical. It means that combination, first of all, meets the quota. If the combination doesn't meet the quota, we don't even care about it at all. And actually, maybe we can, I should have done that before. When you're doing the Banzhaf, I'm going to scroll back up a little bit. We only consider the ones which meet the quota. In this case, the quota is 16. So actually on this chart, everything below here doesn't matter. We only consider the ones which actually meet the quota. Only consider combos which meet the quota. Because you're looking at what are all the various ways that you could actually sort of win in this little election. And then you ask who is it which is actually influencing the winning. All right? So when you're doing the Banzhaf, you only have to consider the combinations which meet the quota. Anyway, who is the critical in each of these different things? what you need to do is look at which voters were required to meet the quota. So, for example, I'm still red. In the combination A, B, C, the total, the first row of that chart, the total was 27. Which is critical? Sorry. I will refresh your memory. The weights here were 12, 10, and 5. Which of them is critical? And the quota is, it's all up there, 16. So you need to ask yourself, these guys, they added up to 27, which of course is more than the quota, but is each one of them actually necessary in order to make it to 16? For instance, what about the C? Do you really need the C to make it to 16 in this case? I say no, because we had 27. If I were to take the C away, that's only 22, but that still makes it to the quota. So here, C is not critical. I'm talking only about this combination, so technically I would say C is not critical in A, B, C, since without C, it still makes the quota. Right? So C is not critical in that combination. What about B? You ask yourself, do I really need the B to make the quota? What do you think? Is C critical? B, I mean. In this combination, I see some heads shaking slowly back and forth. Yeah, the B is also not critical here because it adds up to 27. And if I took away the B, which is 10, that's 17, which still makes it to the quota. So actually, these guys here, they didn't need the B. Even without the B, they still would have made it to the quota. So C is not critical in ABC, since without C, it still makes a quota. And similarly, B also is not critical. That's because, for the same reason, if you were to take the B away, then it would add up to 17, which still makes it to the quota. So you didn't need the B. All right? What about the A? I think actually you really do need the A in this combination because it adds up to 27. If I take the A away, it only adds up to 15, which does not make it to the quota. So A is critical since without A, it'll only be 15, right? Which does not make it to the quota. All right, so in this combination, A is critical and neither of the other two are. Now, it is sometimes possible for more than one candidate to be critical in one of these combinations. But anyway, I'm going to go up here and fill this in. So we had decided, so this is actually, this last sort of column here is actually 3 columns because some combination of A's, B's, and C's could be critical. In the first row, only A is critical. And so I put a check there for the A, all right? This is how I'm going to write the fact that A is critical, B and C are not critical in that combination. Remember, what that means is this combination does make it to the quota, and among those 3 people, A, B, C, you really need the A. If you got rid of the A, you wouldn't make it to the quota anymore. But the B and C were kind of extras. You don't actually need, you need one or the other, but you don't need each individual one. All right, let's continue then. So this was ABC, that combination. Let's talk about the next combination, which is just A and B. Now, eventually, hopefully, you're going to be able to do each of these in your head, but just because this is our first time. In AB, here the total was, sorry to go back and forth. The total was 22. Which is critical. Here the A is, remember, 12 and the B is 10, right? And the quota is 16. So here they are adding up to 22. Is A critical? That means if I take away A, do I still make it to the quota? The answer is if I take away A, I don't make it to the quota. That means A is critical. All right? So A is critical. A is critical. Remember, criticat. This means if we remove A, we won't make the quota. That's what critical means. What do you think about B? You want to show me the thumbs? Critical or not critical? I see some thumbs, some subtle thumbs. I say B should be critical, right? B is 10. Their total is 22, but if I took away the 10, it would go down to 12, and that no longer makes it to the quota. So also B is critical. So up here, I'm going to put checks for A and B in that row. A and B are both critical here. All right? And so on. Can we do the last one here? How about in A and C, they add up to 17. Maybe we could try do this one in our head. Remember, the weights for A is 10 and the weights for B is, A is 12 and B is 10. Is A critical here? I think A is critical. It only adds up to 17. If you take away the A, it certainly dips down below the quota. So A is critical. And C is worth 5 here. If I removed 5, this goes down to 12, which no longer meets the quota. So C also is critical here, like so. All right? And this is the end of the table for the Banzhaf. All right, this is how we do the Banzhaf. Maybe before, the answer is in terms of percentages. I'll tell you in a moment how to do that. I actually had a cute, fun little handout. I know everybody loves handouts, especially the Democrats. Am I right? I got handouts. So these are. The example that I always have in the back of my mind when I'm talking about weighted voting is the Electoral College system, which is a big weighted voting system. Some people believe the Electoral College itself is a type of disenfranchisement in the same way as Banzhaf's example, although it's not anywhere near as extreme. I have issues with the Electoral College other than that issue. Some people love the Electoral College. The last time we had an election, I was in the grocery store and I saw as I typically do, in the grocery store, like the checkout aisle, I saw an issue of Cosmopolitan magazine, which I am usually not interested in what Cosmo has to say, but I saw on the cover one of their little headlines, along with hot sex tips, was it said "Learn to love the Electoral College," and I was surprised that Cosmo was writing about the Electoral College, but I was too embarrassed to pick up the magazine and start reading it because I'm a real man and I don't read Cosmo. But then afterwards, I went home and I tried to look up this article online, and I couldn't find it anywhere. I spent serious amount of time Googling for Cosmo Electoral College. I found a screenshot of the cover of the magazine, and I looked more closely. I realized I had misread it. It said, "Learn to love the Erectoral College." Huh? Yeah. I didn't read that article. It wasn't about the Electoral College. That's what I go to Cosmo for. Hot tips about the Electoral College. I was let down. This is my story about Cosmo and the Electoral College. What I would like to check out on here, let's try and look at the weights of the Electoral College in this kind of Banzhaf way. And what I have shown you here, can we look on this side, which has the 2 columns on it, or 4 columns, I guess? These are the results of the Electoral College in 2016 and 2020. So let's look at the 2016, which is on the left side, Trump versus Clinton. So in 2016, this was the presidential election, Trump versus Clinton. You can see all of the various states and who they voted for. And if you look down at the end, you will see Trump's electoral college total was 306 and Clinton's was 232, which looks kind of like a blowout. And actually, Trump said after the election, this was one of the greatest electoral college victories in history, which is not true at all. There have been much greater blowouts. I don't know why he said that, but it's just straight up not true. This is actually like a fairly typical margin. I mean, he beat her by 70, but that's usually how those things end up. And if you look, just cast your eyes over to the right, it's exactly the same margin that he lost to Biden. So there's nothing remarkable about this. But anyway, the quota is 270 votes that you need to win. So I would let's look at Trump's states, right? And I would like to know which were critical. So his total was 306. The question, which of these are critical, means which of those states on the list did he really need in order to win? Or are there some that he didn't actually need? Like, for instance, the first one, Alabama. Did he really need Alabama to win? The answer is no, because so his actual total was 306. If he lost out on Alabama, his total would have dropped by 9, but that still is enough to win. So the question is, which of these states here are actually critical? Does anybody see any? Are there any? Yeah?
Texas.
I think Texas with 38. If you subtracted 38 from Trump's total of 306, I believe that would go down to 268, right?
Florida.
Yes. Florida. What about Florida?
That's 29.
29. I think 306 minus 29 is still more than 270. I think it's
Tennessee. Oh, wait, no, that's
277. Yeah, like you could see, how much did Trump win by? He won by 36, right, in terms of the quota. The quota is 270, but he's 36 above that. So I think the only state is Texas that would have swapped it if it had gone the other way, right? So in this case, look at Trump states which were critical. I would say Texas is the only one. All right? This seems like the kind of thing that Trump would be bragging about at his various rallies. He said, I won so many states, and any one of them, except for Texas, I could have gone the other way and I still would have won the election. It's true. He wouldn't have said except for Texas. He would have just said any one of them, even though that's technically not true. Yeah, whatever. All of these states could have actually gone the other way and Trump still would have won, except for Texas. So Texas is the only critical voter in that particular combination. All right? And we don't really ask the same question about Clinton because, remember, in the Banzhaf, you only consider the ones that actually make the quota, the combinations which make the quota. So it doesn't make sense to talk about Clinton in the same way. What about Biden? So can we look at on the 2020? In the 2020. So now Biden was the winner, so we should be looking at Biden's combination. In Biden's combination, which are critical? What do you think?
California.
Yeah, I think California is definitely critical. That's 55, and if Biden, you can tell, just look at the numbers. If Biden had lost on those 55, he would no longer have made it to the 270. Any other state? I think none of the other states on that list are critical. It's because Biden exceeded the quota. His total exceeded the quota by 36, and none of the other states are 36 or more, right? Only California is more than 36. So which are critical? The answer is only California. All right. And this is actually kind of typical in the presidential elections. Usually, each individual state is not critical, except sometimes the really big ones. That's a typical result. All right. Maybe we can turn the page over. This is a more interesting example just because this is the Bush-Gore Nader. There's no column for Nader because he didn't win any states. But this is the Bush-Gore example. So this was in the year 2000. Bush was the winner. You can see this was a super narrow race, as we already knew. Bush got only 271, and the quota was 270. So in 2000, in Bush's combination, Bush was the winner, so we look at his combination. Which are critical? What do you say? Yeah? I think all of them, yeah. He only won by one, right? Bush, in terms of the quota, he only met the quota by one vote, which means if any of these states had gone the other way, Bush would have lost, all right? Or actually, if the states had gone the other way, it would have, like if one of the threes, if say Alaska went the other way, Bush would have lost, right? Gore would go up to 270 and Bush would have gone down to whatever, 268 or something. So which are critical? In this case, all of them. All right. What I mean by that, what that means is if Bush had lost any of those states, then he would have lost the election. Super close. The Trump versus Clinton or Trump versus Biden were not nearly as close in that sense. All right. I thought that was just a cute little historical real-life example. Can we get back to doing the Banzhaf, though? I want to, just to finish up this example from before, and then I have one for you all to try in our remaining 10 minutes. So here, we basically did everything. I'm just going to copy this down so I don't have to keep flipping back and forth. The only thing to discuss is just how to sort of say the final answer, all right? So in this case, remember the ranks and the weights and all that were 16, 12, 10, and 5, right? That's the ABC. So the way to summarize the answer, to report the answer. Again, just like the Shapley-Shubik, the answer is a bunch of fractions, which if you like, you can turn into percentages. And the fractions this time are, for each voter, how many times they are the critical. Like A is critical 3 times here, B is critical only once, and C is critical only once. And that's what the fractions look like. So we make fractions, and what they look like is on the top, the numerator of the fraction is number of times this voter is critical. So for A, that would be 3 in this case. For B, it's 1. For C is 1. And then the denominator of the fraction is just the total number of critical checks, right? So in this case, you just look at the total amount of checks there, which is 5, right? There's 5 total. And so in this example, the fractions look like A has 3 out of 5, because there are 5 total check marks there, and 3 of them are for A. B has 1 out of 5, and C has 1 out of 5. All right, and this is how I would expect you to leave your answer on a test or something. If you want to, you can convert this to percentages if you have a calculator. 1/5 is 20%, so this is fairly easy. This is equal to 60%. These are 20%, and this is 20%. All right, so this is how you write the final answer of the Banzhaf. Those fractions are the number of checks for that person divided by the total number of check marks. Any questions about that? I got an example for you all to try of the Banzhaf. Let's try. I think we got enough time. 10, 6, 4, 3. All right, see what you think. You should begin by making this chart of the combos the total weights, and then the critical, A, B, C. The chart should mostly look the same as the other example. The combos should all be the same. All right, let's chat about this. It looks like people are doing fine. The combos are ABC, AB, AC, BC, A, B, C, and nobody, right? Those are all the various combinations of 3 voters. And then the total weights here, we add them up. A plus B plus C here is 13. Just A and B would make 10. A and C would be 9, B and C would be 7, A is 6, B by itself is 4, C by itself is 3, and then nobody is 0. And we only need to consider the ones which actually make it to the quota. So the quota is 10 here, so actually all of this we don't have to do. In this, because of that, I think this ends up in practice being easier to do than the Shapley-Shubik, just because the Shapley-Shubik you always have to do all the rows and figure out the pivotal for every single row. Here, most of the time you end up scribbling out most of the rows anyway. So I only need to consider the first 2 rows. And in the first row, who is critical here? What did you say? A and B. Yeah, when they made it to 13, you have to think separately for each of them. If you took away 6, then this no longer makes it to 10. So A is critical. If you took away 10, that's the B. Then this goes down to 9, which is no longer making it to 10, so B is critical. If you take away the C, which is 3, this goes down to 10, which is still making the quota. That means the C was not necessary here. C is not critical. So those are the checks that I get in the first row. And in the second row, here we're making 10 exactly. That means if I lose out on anybody, it's no longer going to make it to 10. So in this case, both A and B are critical. Not C, of course, because C is not even part of this combination. So I hope those are the check marks that you got. And then the answer, to sort of summarize, the answer is the fractions. And each time the fraction is how many checks does this person have divided by the total amount of checks. A got 2 checks out of 4 because there's a total of 4 checks. B has also 2 out of 4. C has 0 out of 4. So if you like percentages, this is 50%, 50%, and 0%. That means C is a dummy, which you could have told, you can tell that just by looking at the original setup. All right, I hope that's what you got, and I think that'll do. Please let me know if you want to talk about the homeworks. I'd be happy to go over them.